All right, let's take a look at some subsequential limits. Let's see if we can build some degree of intuition. So we're not going to formally prove these things. We're just going to use some intuition to see what we think might be true. So here, if we're looking at our sequence 1 over n, so that sequence we know converges to 0. So 0 is for sure a subsequential limit. When a sequence converges, every subsequence is going to converge to that same value. We've already proven that. So that's the only choice. The lim sup then is a number. It is 0, so these are not sets. The lim inf is also going to be 0. Here, when we look at our second example, so this example right here, notice that if we just defined a sequence of only these even terms, so if we only looked at that subsequence, that is going to converge to 2. If we only looked at the subsequence of these odd terms, then that subsequence converges to -2. Every other subsequence would either converge to -2, converge to +2, or oscillate, bounce back and forth in some fashion between -2 and +2. So our lim sup, our least upper bound is going to be 2. Our greatest lower bound for this set is -2. In our next example there, this 5n minus 2 over n plus 4, that sequence, it converges to 5. Since it converges, its lim sup and lim inf are going to be the same value. The next one I think is a little bit tricky. When we look at the sign of n, I'm going to make a kind of broad general argument or suggestion. And I'll say that every single value from -1 to +1 could possibly be would be a subsequential limit, that we could come up with sequences that converge to each one of these values, subsequences of this. I'm not going to do that constructively. That would be pretty tricky. But that's maybe the intuition that I have, right? So you're thinking about a sign graph, and then you're just going at the integer places along that sign graph all the way out for forever. And I would argue that we could come up with sequences that go on forever that are going to converge to any one of those values between -1 and +1. So our lim sup is going to be 1. Our lim inf is -1. For our next example, we have 3 minus e to the -n and 3. So it's going to bounce back and forth between these two things. It is going to converge to 3. It converges to 3, and so that is going to be the lim sup and the lim inf again. When we look at our next example, this sequence, this is going to be a little bit more than 2 over, a little bit more than 2, then a little bit less than 2, then a little bit more than 2, then a little bit less than 2. So that sequence converges to 2. So every subsequence is also going to converge to 2. When we look at cosine of n times pi over 2, there we're going to have really those values that are bouncing between -1, 0, and 1. So -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0. So you could define a subsequence that converges to -1. You could define a subsequence that converges to 0, or one that converges to 1. So in that case, our lim sup is going to be 1. Our lim inf is going to be -1. Here, when we have something that is divergent, this thing is heading off towards positive infinity. that tells us that every single subsequence is going to also diverge towards positive infinity. If we have a sequence that is defined in our next way, okay, so the square root of 4 plus 2 over n, that sequence converges to 2. So our lim sup and lim inf, they are not sets, they are just numbers. Just numbers, that's the eraser, there we go. So the lim sup and lim inf are both 2. For our next example, when we have 4 to the n whenever n is even, and 4 to the negative n when n is odd, we could have something that is 0, or we could have something that is heading towards positive infinity. So we have our lim sup and lim inf here. We'll go ahead and finish this up since we are close. We're right there. This next sequence is going to have, it converges to 0. So those values are both going to be 0. In our final sequence, it diverges to positive infinity. So we have our lim sup and lim inf are both positive infinity. All right, that's what we have for some examples. You can use those to start to build some intuition on subsequences and lim sups and subsequential limits. All right, we will talk to you in the next section.